All right, so September 16th, we're starting with quadratic functions today. And again, just like before we started with the calculator, I gave you a whole bunch of notes, okay? And same thing here. Okay, so the linear function, which is what we started with, right? A linear function has the equation y equals mx plus b and produces a straight line. It has a degree of 1, important, right? Because, that's what BC stands for, because the highest power of x is 1, okay? I'll make a note here. Y equals mx plus b can also be written as y equals ax plus b. And next year, we're going to shift away from the m, because in grade IPR, all we dealt with is linear equations. So we call it m, so that's slope, right? We call it slope. But from now on, this year, you're going to be introduced to quadratic equation, which is x2, right? X to the power of 2. Next year, you're going to also be introduced to x cubed, which is x to the power of 3. So we shift away from the m and call whatever is in front of the highest power of x is a, right? Where a is the leading coefficient. A is called the leading coefficient. Okay. And it tells us things, right? Like if we just look at A, or what you used to know as M, it tells us if this line is going up or down, right? Is it increasing or decreasing? So A tells us a lot of things, okay? A quadratic function, on the other hand, right, has the equation y is equal to ax squared plus bx plus c. And produces a parabola. And what is a parabola? A parabola is it's a horseshoe shape. Okay. We'll say we say that it has a degree of 2, comma, because the highest power of x is 2. Highest power of x is 2. Make sure you write this down, and I'll make a note. Right, note a is in front of x squared, right? Making it the leading coefficient. That's note number 1. Also, y is equal to ax squared plus bx plus c, right? B and c can be 0. Okay, that's a very important because students think, oh, so it's always going to look like this? It's always going to have 3 terms? No. B and C, like these two here, can be, like they could just not be there. They could just be, if B is 0, this whole thing goes to 0. If C is 0, it's just not going to be included. So make sure you know that, okay? A quadratic will always produce a parabola. Comma, which which expands indefinitely. Right? It points up or down, comma, but never sideways. It can point up or down, but it will never point sideways. Okay, so that's a so we're gonna have a few sketches here. Watch that the graph is not a U, okay? A U, actually, those arms will open up and then just run parallel. That would not be a quadratic. It has to keep on expanding indefinitely, okay? So just sketch, okay? So there you have a bunch of different lines being graphed, or curves, right? Some of them are curves. And so we're going to go across them and identify which one is a quadratic and which one is just nothing, right? Or linear, okay? Okay, so this has that horseshoe shape. So this is actually a quadratic. A degree of 2, right? This one almost looks like it at first, but you need to see that it's going to go back up, right? This kind of starts, then it goes like this, but it doesn't go back up. It gives you an indication that this will actually continue down. So this is nothing for us, okay? This is a quadratic. Yes, it opens, this one opens down. You can tell that the arms are going to expand, and this is going to keep on getting bigger. It's like a bowl, right? It just keeps on getting bigger, and so it's a quadratic, and the degree is also 2, okay? This one you should recognize. That is definitely not a quadratic. That's a linear, and the degree is 1, right? It's just going to be y equals x, something like that. This one, a lot of students would call this a linear, but this is actually a constant. It's a constant function. This would be y equals 5, let's say, right? It'd just be y and a number. There would be no x variable here. And this one is nothing either. I guess I should say, if it's a constant, do you know what degree it has? If it's just a constant? Anybody brave enough online? If it's a constant, what would be the degree of that function? There is no x in there, right? 0, that's right. So degree 0. Okay. So we've got a couple of nothings, and then we've got the ones we recognize, right? But the main ones are the quadratic ones, okay? So let's keep going. State whether the equation is linear, quadratic, or other. So I'm just going to write a whole bunch of them down. So we're going to put down degree here in one column and type. All right. So we're going to examine each equation once we've written them down, of course. right? Okay, so by observation, okay, we have the option of linear, quadratic, or other. Remember that with linear, the degree is 1. A quadratic would have a degree of 2. And then anything that we don't recognize would be other, right? So in this case, y is equal to 7 plus x. Somebody just flipped this on us, right? But we do recognize that the degree is 1. So the highest power of x is 1, so this would be a linear. Okay. Notice that f of x is the same thing. If you ever see f of x, you can just think of it as y equals as well. Okay, they can be used interchangeably. Nothing wrong there. And here you should recognize that, right? The highest power of x, there's a 1 here, there's a 2 there, but the degree overall is the highest power of x, so this is a quadratic. X to the power of 3, the degree is 3, and we'll just call this other, even though it is actually called a cubic function. Okay. What's the degree of this function here, or of this equation? Technically it's 1, right? But do you remember, oh, this is IPR, you're going to love this, right? Technically, if you bring this up, it would have a -1 exponent, right? If you bring the denominator up to the numerator, the exponent sign changes. So technically this has a -1 degree, and this should just be other. Okay, we don't really worry about these two in general. What about this one here? F of x is x minus 2 squared plus x plus, sorry, plus 3. What would the degree be of this one? Well, x minus 2 squared is really saying x minus 2 multiplied x, right? X minus 2 times x minus 2 plus 3. That's what this is saying. If you FOIL this, right, if you were to distribute this, you would end up with an x squared. Okay, so we know therefore that it's 2 is the highest power of that. So it's a quadratic. It just doesn't look like the one I just presented to you, but if you FOIL this out, you will actually end up with an ax squared plus bx plus c, all right? Same here. These two will result in an x squared, right? If you multiply this times this, you get an x squared terms out of that one. So this is also a quadratic. The nice thing is we can type this into our calculator, okay? And check. So let's take your calculators for a moment here. Y equals, let's clear everything we have in there. Let's type in this one here. So I'm going to use my brackets. So x, right? X minus, you're going to actually subtract x minus 2, close that bracket, and then open the second bracket and go x plus 3, close bracket. So you're essentially copying exactly what you see here. Got it? Hit graph. I hope you can see it. I'm pretty sure you will see it. Yeah. Blows your mind, right? So could you, let's say you're stuck on a quiz or test and you're like, I have no idea, right? Type it in, right? You can always type it in and know for sure. Okay, this definitely looks like a quadratic, and we're good to go. Let's try this one up here, this one. So I'm going to go to y equals. I'm going to just, I don't always erase right away because I have a feeling sometimes I'm going to need it later. So I'm going to go just, if you erased it, not a big deal. I'm just going to enter this one into y2. How would you do that? Brackets, right? Brackets, x, subtract 2, close bracket. We're going to use our x2 button, which is along the left here. And then we're going to go plus 3. careful not to enter the +3 up with the exponent. So sometimes if you do it too quick, let me see if I can replicate that mistake. Like if you go 2 and then go +3, that's not gonna look good. Okay, you gotta make sure you go arrow sideways so you drop back down. Okay, hit graph. I don't know. Yeah, you will be able to see that. Okay, so definitely a quadratic, and if you turn on both, you just have two curves now, not a prop. Could you find the intersection, you think, of those two? Second trace 5, boom, 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 you're there. Okay. Do you think they're going to meet again? They're meeting here. Do you think these two curves are going to possibly meet way up here? We don't know, but it could be, right? I would say it depends on how it goes, right? If this one opens quicker than this one, they probably won't. Anyways, so let's put the calculators away. I just wanted to show you that it's a neat feature. And so now we're going to do more properties, so more notes. So I probably won't be able to assign any homework today because we're not done yet. Oh, sorry, not one yet. I'm going to first label as properties, okay? Properties of quadratic functions. And remember, in general, it looks like this. But I told you that B and C could be absent, right? They could be 0, and then they're not necessarily there. So don't panic if you don't see that, right? So 1, the direction of the opening is determined here's that word, leading coefficient, which is the variable a, okay, comma, which is always in front of the x2 term. If a is positive, it opens up. Okay, so you would have something that would always, you know for a fact that it's pointing up if a is positive, right? So examples, right? Y is equal to 2x squared, or y is equal to 3.75x squared minus 2, right? Or y is equal to 50x squared plus 7x. It doesn't matter. You just look at, find my x squared term. It's positive. It's positive. It's positive. It doesn't matter how big the value is. They're all positive, right? So let's connect them all. A is all positive, all pointing up. Okay. Therefore, if A is negative, it opens downward. right? So the graph would look like this. Okay? And so examples would be y is equal to negative 2x squared, y is equal to negative 1/2 x squared plus 18x. Let's do an f of x, why not? F of x is negative 7x squared. It doesn't matter what follows, it's always a negative, right? Every single one of these, and if you don't believe me, you could enter them into your calculator and see for yourself. Okay. So if you get the equation and you look at the a value right away without even graphing it, you should be able to tell. You know it's going to go down, right? So I think that's all I'm going to say about that. We're going to keep going. So and then next page. Were we done copying? Yeah. Okay. Number 2. The value of a also determines the width of the parabola. Okay. So you have wide, normal, narrow. Okay. I'm going to start with a normal first. Okay. So the normal scenario is when a is equal to 1, right? So your example could be y is equal to x squared, right? Or y is equal to x squared plus 1. Or y is equal to x squared plus 3x plus 4, right? In every single case, the leading coefficient is always 1. We consider that a normal opening when we talk about width, okay? And it's always going to look somewhat like this. So we just make your parabola and you make it go up like that, okay? And we're going to be a little extreme here. If a is less than 1, but bigger than 0, obviously, it's a wider one. So we're going to make sure it looks a lot wider than this one. And examples would be any decimal, really, like 0.85x squared, or y is equal to, it could be negative as well. Okay, so not looking at the sign, I'm actually misleading you a little bit here because this parabola is pointing up and you're going to look at that as like, how come this one is pointing up? So can we get rid of the negative? So you're not looking back later and saying like, why did he graph it like this if it's pointing down, okay? But the truth is, if you just look at the value, these are all values between 0 and 1. So even if this had been negative, we would still consider it a wide parabola. It would just be pointing down, but it'd still be, the opening itself would be wide. Okay, so narrow, we're going to make it very obvious. It's going to go like this. So, and the examples would be, right, you could have f of x is equal to, sorry, I'm jumping the gun here. So a would have to be greater than 1. A greater than 1, a is equal to 1, or in between 0 and 1, so a decimal, okay, or a fraction. So anything bigger would be 3x squared, y is equal to 5x squared minus 1, or f of x is 7x squared plus 5x, for example. So in every single instance, a is bigger than 1 here. So this question is simply looking at the opening, which you don't look at the sign. The sign tells you which way it's opening. Is it up or down? The value of a, like the actual number, tells you if it's going to be wide, normal, or narrow. Okay? Oh, some folks are still copying, so go ahead.